I want to be the very best. All right, 3.4, feasible region. We will focus on graphing. If you guys have graph paper, please use it today. The graphs need to be as accurate as possible. All right, here we have an example of a feasible region. If you look at the PowerPoint, there's actually a lot of information on here. Your homework will have a lot of information as well. The first thing you see is the profit equation. It's an equation that each problem will have to help you calculate what type of profit will be produced. If you'll have a lot of profit, a little profit, what's the maximum profit? Sometimes it asks for a minimum profit. And then on the right hand side, you see some critical points, but they're not there yet because we're going to find those critical points. And then back to constraints, and that's what we'll focus on right now. Basically, they're going to ask you to go ahead and graph all 4 of those inequalities. It looks like 3, but there's actually 4. All right, let's go ahead and do the green one first. The green one is in standard form. When inequalities or equations are in standard form, I like to use the cover-up method to plot the x and y intercepts. I know some of you guys still like to change it to slope-intercept form, find the y-intercept and the slope. Whatever methods you want, you can do, but I'll do my cover-up method. I'm going to cover up the y to solve for x, and that gives me 4 in the x-axis, so I'll plot a 4. And then I'm going to cover up the x and then solve for y, and that should give me a 6 on the y-intercept. And there's my line for the green. Now with inequalities, remember we have to shade. There's shading involved. And so I like to choose 0.00 as the testing point. When I plug 0 for x and I plug 0 in for y, I get 0 is less than or equal to 12, which is true. Now normally I would scribble all over the graph, but we're going to be a little bit neater today. Instead of scribbling, I'm just going to throw in some little arrows because that's a lot neater than scribbling. So we're going to try that. Let's go ahead and do the second one, the orange one. That one's in y-intercept form, so go ahead and plot the 2, and then using the slope, you go up 1 over 2, and you should get the orange line. Also, we have to figure out where to shade with this one, plugging in 0, 0. I have 0 is greater than or equal to 2, and that is not true, so do not shade over the 0, 0. Instead, you're going to shade away from the 0, 0. All right, so far our overlapping, because that's the feasible region where all of the graphs overlap, is all in here. Oops. All right, but again, we're going to try to avoid scribbling, so I'm going to take that away and just remember that that's where they overlap. Now, this last part, I said it looks like there's just one equation, but there's 2 inequalities all in there. And so we're going to do both of them. This is the first one. X is greater than or equal to 0. Remember, x equals are vertical lines that go straight up and down. And so when they say x is greater than or equal to 0, they're talking about this line right here, and then greater than. Oh, there it is. And then the other one next to it, y is greater than or equal to 0. That's this line, and then up. And I put these together because I wanted to point something out. They usually go together. Whenever you see these two, that just means that you're only going to work in the first quadrant. So that's what that means is you're only going to work in the first quadrant. All right? All right, so knowing that, let's go ahead and figure out where all 4 of those inequalities overlap. And you're going to go ahead and color that in the darkest. In this case, all 4 overlap right in here. All right. So that's where all 4 overlap. So it looks a lot neater when we don't scribble all over the place and you do those little arrows to remind you of where the shading is. All right, all of that, and we're still not done because now we have to figure out some critical points. What critical points are basically the corners of our feasible region. Oh, by the way, the red part is called the feasible region. It's the region we're dealing with. And the critical points are the corners of the feasible regions. Here they are, 0, 2, 0, 6, and then 2, 3. Those are the critical points. And now what we're going to do is we're going to take each critical point and plug it into the profit equation. All right, take in 0 and 2, plug 0 for x and 2 for y, and that should give you a profit of 10. And then plug 0 in for x and 6 in for y. That should give you a profit of 30. And then of course plug 2 in for x and 3 in for y, and you should get 21. Now on the homework, they might ask, what is the maximum critical point? And so your answer would be 0.6 is the maximum critical point because it produced the maximum number, the largest number. Sometimes companies use these graphs to find a feasible region, and then they use those critical points to see what will produce the maximum dollar amount, sometimes the maximum production of something. But sometimes they will also have graphs where they ask for the minimum. And so if they're asking for the minimum point, 0.2 would be the minimum. All right, so that's how you do these things, is you just graph all of them, see where all of the shaded region overlap, and then find the critical points, and then find the max and the min. All right, let's do another one just for fun. Actually, we have one more after this, so we're gonna have lots of fun today. Notice the profit equation is a different equation now. We have new constraints, and so we're going to be looking for a different feasible region. Let's start off with the blue inequality. Again, the blue one is in standard form, so I usually use the cover-up method, cover up the x to get the y-intercept, cover up the y to get the x-intercept, and there's my line. And then I'm going to test out 0.00 to see if my testing point is true or not true. And if I plug in 0, 0, it looks like 0 is greater than or equal to -6. So 0, 0 is true. That means I'm going to shade below. Let's go ahead and do the green one. Now the green one looks a little bit weird because it's 2 is less than x is less than 4. Now we've never seen a graph in that form, so pay close attention. We have seen equations of graphs where it's x equals something, or x is greater than, or x is less than, so x something. And so in this case, x something are vertical lines. But in this case, there's 2 vertical lines, one at 2 and one at 4, like that. And they're dotted lines, because if you notice it's not less than or equal to, it's just less than. So a vertical line at 2 and a vertical line at 4. And guess where the shaded region is going to be for them? Good guess. The shaded region is going to be in between those two lines. So if you have those two lines, it just means that X is in between those two. All right, so that's the new part, so be careful. And then finally our orange region, y is greater than or equal to -3. Remember, y equals graphs are horizontal. So y is greater than or equal to -3. When you plug in that line, you get that. But now we're going to test it. Which shade do we shade up or shade down? A lot of you guys look and go, y is greater than. So if it's a greater than sign, shade up. That is true. But if you want to use a testing point like 0, 0, if you plug 0 into the y, you should get 0 is greater than or equal to -3, which is true. So that means shade up. All right. Now we're going to go ahead and darken the shade where all of them overlap. And so it looks like all of them overlap in here. And there. Okay, so go ahead and shade that in with your pencil. But that is our feasible region. And this feasible region has 1, 2, 3, 4 critical points. There they are. And you're going to take each critical point and plug it into the profit equation. Plug in 2 and 0. You can do this in your head fairly easily to get 4, to get 8, to get 8 again, and to get 13. Of course, this will be our max because it produced the highest number. And then this is our minimum point because it produces the lowest. All right, these aren't too bad. They're just graphing more than one on the coordinate plane just to see where they overlap. The hardest part is to see the correct overlappage. Last example for the day. Now it looks like the same as the two other examples, and usually I don't want to repeat the same concept, so this probably has something special about it. All right, again we have a different profit equation, P equals X plus Y. That's a pretty simple one. Notice this X is greater than 0, Y is greater than 0. Remember, that means that we're only going to be working in the first quadrant, so you don't have to worry about any other quadrants. Let's go ahead and graph the green inequality. That's in slope-intercept form. Start at 1, and then the slope is up 1 over 1. There it is. Plug in 0, 0 to test out to see if it 0, 0 is good or no good, and it turns out that 0, 0 is less than 1. So we shade towards the 0, 0. The orange one, it looks like the x-intercept is 4 and the y-intercept is 4. So there it is. Plug in 0, 0. It turns out that 0, 0 is not true. So we shade away. And then of course the x is greater than or equal to 0, y is greater than or equal to 0. That means only that first quadrant. So where do all of those overlap? It looks like they overlap here. In this part. And this goes on forever, by the way. But it still has some critical points. We have this as a critical point, and we have this as a critical point. I'm going to erase it a little bit. Oh, I erased it all. So we have 2 critical points, and then the shading is all in here. It's not always going to make a shape. It doesn't always make the triangle. Sometimes it just goes on forever in one direction. But we still have some critical points. This one's fairly easy to see. It is 4, 0. But if you notice, this one is not very easy to see. It's not right on the corner anywhere. So this critical point is a lot harder to find. How do we find that critical point? Well, it's the intersection between the green graph and the orange graph. And so there's a few ways to do that. I showed you how to graph them on the calculator. You can also do whatever method, substitution method, elimination method, graphing method, any method you want. But in order to do that, we're going to change them to be equals. So y equals x plus 1, and then x plus y is equal to 4. And so that's our system. If we solve that system, we'll figure out what point they intersect at. All right, so go ahead and solve that system. I would use substitution. By substitution, I take that and I substitute it into the y to get this. Simplify, divide. I should get 1.5, and then plug it back in to the x to get 2.5. All right. So when the graph is not clear, you can use substitution method or elimination method to find where they intersect. So now here are our 2 critical points. 1.5, 2.5, and 4, 0. Plug those in to the profit equation. The 1.5, 2.5 gives you a profit of 5, and then the 4, 0 gives you a profit of 4. So we have a maximum value and a minimum value. All right, so that's the last one. That one was different just because the region goes on forever, but you still have critical points, and then the critical points were a little bit difficult to solve for because you had to use more methods. All right, sorry, that was only 3 slides, but it turned out a lot longer because there was a lot of explanation. So go ahead and try the homework yourself.